Intertropical Convergence Zone (ITCZ) is a ribbon of atmosphere near the equator with only a few hundred kilometers wide. It has persistent convergence with northeast trade winds and southeast winds, and it appears as a band of clouds consisting of showers with occasional thunderstorms. In order to learn more about the ITCZ, we need to answer two questions. Why does ITCZ converge with clouds and rains? And why does ITCZ converge with easterly trade winds or easterlies? Firstly, in order to explain the convergence clouds and rain near ITCZ, we need to explain the atmospheric convection cell. Because of the direct sun rays, the atmosphere at the equator is warm. Because of greater buoyancy, the warm air rises with great moisture at equator, making the equatorial have low pressure near the surface and high pressure at the upper troposphere. As the air rises, it cools by expansion and the heat radiating to the space. Then its relative humidity increases, and clouds and rain may result. That's the reason why ITCZ contains plenty of clouds and rains. After the precipitation, the pressure gradient makes the air move outwards away from the region of developing thunderstorms. At about 30 degrees north or south, the dense air falls towards Earth's surface. Since the air is relatively dry, it may form desert at the latitude. Once the air reaches the surface, pressure gradients cause air to move along the surface towards the equator. Then the atmospheric convection cell forms, and the center is ITCZ. We may want to ask why the cells extend only from the equator to about 30-degree latitude. We'd like to answer this question with another important question. Why does easterlies form? As the air moves from the equator to higher latitude, it experiences a clockwise rotation in the northern hemisphere and a counterclockwise in the southern hemisphere because of Coriolis force. What is Coriolis force? The Coriolis force is an inertial force that acts on objects that are in motion relative to a rotating reference frame. An object moving horizontally in any direction on the surface of the Earth experiences a Coriolis force perpendicular to the direction of motion, to the right in the northern hemisphere and to the left in the southern hemisphere. The Coriolis force tends to produce a geostrophic longitudinal flow by balancing the meridional pressure gradient force and make the further poleward transport difficult. When the air converges at the surface, it moves from higher latitude to equator. The Coriolis force on the right side of the flow in the northern hemisphere makes the surface trade winds also tend to move parallel to the latitude, which is the easterlies. At last, we want to figure out what is the effect of ITCZ to the weather. The ITCZ area is full of clouds and winds, while the subtropical high-pressure belt is full of dry air, leading to little rain. The ITCZ follows the sun in that the position varies seasonally. It moves north in the northern hemisphere summer and south in the northern hemisphere winter. Variation in the location of ITCZ dramatically affects rainfall in many equatorial nations, resulting in the wet and dry seasons of the tropics. Longer-term changes in the ITCZ can result in severe droughts or flooding in nearby areas.